All right, if you're getting ready for the Azure ML exam, you know some topics are just heavier than others. So today, we're going to do a super high-value cram session on one of the biggest ones, data management and preparation. Let's get you locked in for those questions.
So why are we starting here? Well, check out this number, 20 to 25%. That's potentially a full quarter of your entire exam score, all riding on how well you handle data. Getting this right isn't just a good idea, it's absolutely essential to pass.
Here's our roadmap for today. First, we'll cover how to connect to data with data stores and data sets. Then, we'll jump into cleaning up messy data. After that, we'll transform it with some feature engineering, and finally, learn how to monitor it for data drift. And we'll wrap it all up with some real exam-style questions to make sure all this stuff really sinks in.
Okay, let's dive right in. Before you can do any of the cool, fancy machine learning stuff, you've got to get your data into the workspace. I mean, it's the first and most fundamental step of any project, right?
First thing you need to get your head around is the data store. Now, don't think of this as the data itself. It's more like a secure keychain. It holds the keys, the credentials, to your data vault, whether that's blob storage, a database, whatever. This is a really big deal because it means you aren't hard-coding passwords and access keys into your scripts. That's a huge win for security and makes your code way more reusable.
Now, this table, this is pure gold for the exam, because the exam loves scenario questions. If you see a question that mentions automated pipelines or CI/CD, your brain should immediately go to service principal. That's the go-to for enterprise automation. And if they ask about the absolute highest level of security, especially on Azure ML Compute, it's managed identity, because with that, no credentials ever even get stored.
Okay, so if the data store is the key, then the data set is the map. It's a pointer that tells Azure ML exactly what data you want to use. The distinction here is super important. Got structured data like a CSV or a SQL table for a regression problem, you're going to use a tabular data set. But if you're dealing with, say, thousands of images for a deep learning model, you'll want a file data set. That way you can efficiently mount them without having to copy everything.
So we're connected, but let's be honest. Data in the real world is never perfectly clean. It's messy. So now we've got to deal with it. This is a massive hotspot for the exam. You will 100% get questions about how to handle incomplete or dirty data.
Think of this table as your playbook. The exam won't just ask what these things are, it'll give you a scenario. If you see the words imbalanced classes, like in a fraud detection problem, your answer is SMOTE, period. See time series data? It's got to be LOCF, which just means last observation carried forward. Oh, and here's a pro tip. If your data has crazy outliers, always choose median over mean for replacement. That one detail could easily be a point on the test.
So you've connected to your data, you've cleaned it up, now it's time to shape it. Feature engineering sounds really complex, but it's just about transforming your raw data into features that make it easier for the model to find the patterns.
And here's your cheat sheet for that. The big distinction to lock in is between normalization and scaling. If your data kind of looks like a bell curve, you'll want to use z-score scaling. If it's all over the place, min-max normalization is your friend. And for categories, well, if there's a natural order, like low, medium, high, you use label encoding. If there's no order, like a list of colors, you have to use one hot encoding so the model doesn't accidentally think green is worth more than red.
Okay, so the model's trained, it's deployed, our job is done, right? Well, not so fast. The real world is constantly changing, and that means your data changes too. This is called data drift, and it's a critical concept for making sure your model stays accurate over time.
So, how do you catch this drift? It's a pretty logical four-step loop. First, you establish a baseline. That's the data you originally trained on. Next, you monitor the new data that's coming in. If the new data starts to look statistically different from the old data, bam, you trigger an alert. And the final step, the action, you retrain your model on this new, fresh data so it can stay relevant.
All right, we've covered the concepts. Now for the fun part. Let's run through some questions that look a lot like what you'll see on the real exam and see if you can put all this knowledge to work. You ready?
Okay, question 1. It's a classic. A credit card fraud data set where fraud is super rare. Because of that, your model is just learning to say not fraud every time. What tool do you use to fix this? A, B, or C? I'll give you a second to think about it.
And the answer is B, SMOTE. The keyword here is imbalanced. Remember, SMOTE is so powerful because it doesn't just copy the few examples you have. It creates new synthetic fraud samples, which helps balance the dataset and forces your model to actually pay attention.
Question 2. Now pay close attention to the details here. You have a small data set with missing values scattered across many columns, and you want something that's easy to set up. Which cleaning method is the best fit?
The right answer is B, probabilistic PCA. Look, mice is really powerful, but it can be slow and complex. Probabilistic PCA is designed for this exact scenario. Small data sets with a lot of missing values where you need something faster and simpler to get the job done.
Question 3 is a classic trap, so watch out for this one. You're building a model to predict future stock prices. You have to split your data to train and test it. How do you do that without accidentally cheating?
The answer has to be B, the relative expression split. You can never, ever, ever randomly split time series data. If you did, your model would get to peek into the future to make its predictions about the past. That's called data leakage, and it's a huge no-no. You always have to split chronologically. Train on the past, test on the future. Okay, next up. You've got 100,000 images sitting in Azure Blob Storage. Your top priority is efficiency. You want to minimize data movement. What is the absolute first step you should take in Azure ML?
The correct first step is C, register the blob container as a data store. This goes right back to what we said at the beginning. It creates that secure link, that keychain. Then, your next step would be to create a file dataset which lets you mount the storage directly to your compute cluster. This way, you're not wasting a ton of time and bandwidth copying all 100,000 of those images.
All right, last practice question, and this one's about the tools. You're in the Azure ML Designer, the drag and drop interface. You need to pull a CSV file directly from a public website into your workflow. Which module do you grab?
And the answer is A, the import data module. It's really that straightforward. That module has a specific option right in its dropdown for web URL via HTTP. You just pop the link in there and you're good to go.
So, you've aced the practice questions, you've got these concepts down for the exam. But I want to leave you with one final thought. That data drift we talked about, it's not just a test concept. It's happening right now in real-world models everywhere. The real question is it happening to yours?